All right, let's jump right into one of the greatest mathematical detective stories of all time. We're going on a hunt for a legendary proof, a hunt that instead uncovered a set of secret formulas that were hidden for decades in the notes of the absolute genius, Bernhard Riemann.
I mean, just think about that for a second. What if the Riemann hypothesis, that colossal, unsolved problem about prime numbers, was this close to being cracked? That's the question that has kept mathematicians up at night for generations. And for the longest time, everyone thought the key was locked away in Riemann's private papers, just waiting to be found.
So here's the setup. In a letter, Riemann basically teases this new way of looking at his zeta function, but he says it's not quite, well, simplified enough to publish yet. So when he died, the entire mathematical world just held its breath. The search was on for his Nachlass. That's his collection of unpublished notes, because everyone was hoping to find that one final, beautiful proof. But after decades of searching, the bombshell dropped. The brilliant C.L. Siegel, who had spent ages sorting through these chaotic, scattered notes, finally made the announcement. The proof? It wasn't there. The Holy Grail was missing. But, and this is the important part, this isn't a story about failure. Oh no, this is a story about discovering something even more fascinating. Because what Siegel and the others found buried in all that paper were two absolutely incredible, powerful formulas. They weren't the answer to the hypothesis, no, but they were something else entirely. They were a peek into Riemann's private toolkit, and they showed the world just how far ahead of his time he really was. So let's decode the first of these secret clues. So this first major clue was this strange, really beautiful new way to represent the zeta function. It wasn't some elegant, abstract proof. It was something incredibly practical, a tool for calculation that was astonishingly precise. We're going to call it the calculator's tool. Tucked away in these loose notes, they piece together what's known as a semi-convergent series. Now, I know, that sounds super technical, right? But think of it like this. It's a special kind of infinite sum that gets you incredibly close to the right answer, fast. But, and here's the trick, if you add too many pieces, it actually starts to drift away again. The real genius, which Riemann totally mastered, was knowing exactly when to stop. It was his recipe for getting a ridiculously accurate picture of the zeta function. And here it is. Wow. Okay, let's not get bogged down in all the symbols. Let's just look at how it's built. This first part, the sum, that's like your first guess. It's a pretty standard approximation. But the real magic, the secret sauce, is in this second part, this huge remainder term. This isn't just some tiny correction. It's a whole engine of complex numbers and functions, all designed to zero in on the true value with just breathtaking precision. This was Riemann's secret weapon. So how does this incredible machine actually work? Well, let's break it down. First, you've got that starting sum, which gives you a rough ballpark figure. Then, step 2, you bring in that super sophisticated correction term, which refines that guess like crazy. And here's the really brilliant part. The number of terms you use in that first sum, it's not fixed. It actually changes depending on where you're doing the calculation. It's like a dynamic, self-adjusting calculator. And get this is what really shows you its power. Riemann himself, with just a pen and paper, used this exact formula to figure out the location of the very first important zero of his function. And the number he got was about 14.13. Now today, with our supercomputers, we know he was off by less than 3 parts per thousand. I mean, that is just astounding precision for the 1860s. But that was just one half of the story, right? That was the practical tool. The second secret formula wasn't for computation. It was for something much deeper, for theoretical understanding. If the first clue was a calculator, the second one was a key, and it was designed to unlock the fundamental structure of the zeta function itself. And this is just wild. This key was hiding in plain sight the entire time. For nearly 70 years after Riemann died, mathematicians were poring over these notes, and this second formula went completely unnoticed. It was just another, seemingly random integral on a page, until 1926, when someone finally realized what it actually was. And here is that second formula. Now, right away, you can see this is a different beast entirely. Unlike the first one, this is not an approximation. That integram on the right is exactly equal to the function on the left. This integral representation, reveals the function's hidden soul. It is a statement of perfect, profound symmetry. So why is this such a big deal? Well, this formula reveals a deep internal symmetry in the zeta function. It proves that the function behaves in this perfectly mirrored way. If you know its value at any point, let's call it s, this formula instantly tells you about its value at the mirror point 1 minus s. This relationship is the famous functional equation, and what the note showed was that Riemann had found a totally new, powerful way to get there. A secret he just kept to himself. Okay, so after uncovering these two massive clues, the calculator's tool and the theorist's tool, what's the final verdict on Riemann's lost notes? After this decades-long mathematical detective story, what did we actually learn? Well, what they really show us is the incredible range of Riemann's mind. On the one hand, you've got this approximate but stunningly precise tool for just grinding out the numbers. And on the other, you have this exact, perfectly symmetrical formula for understanding deep, theoretical truth. He was a master engineer and a master architect of mathematics, all at the same time. So let's just sum up the big takeaways. No, the proof of the Riemann hypothesis was not in there, but the notes proved something almost as important. Riemann's analytical technique was light years ahead of everybody else. In fact, that calculator formula was so advanced that its most important part had to be independently rediscovered 60 years later by the giants Hardy and Littlewood. These formulas weren't the final answer, but they basically built the road for everyone who came after. You know, C.L. Siegel himself really said it best. The true legacy of these notes wasn't a single answer, but a raw demonstration of power. The sheer force of Riemann's technique, especially in cooking up that first complex formula, well, it just showed a level of mastery that continues to inspire mathematicians even today. So in the end, the treasure hunt didn't turn up the treasure everyone was looking for. But maybe, just maybe, it uncovered something more valuable. Not the destination, but a map, filled with new roads and powerful new tools, showing all the future generations of mathematicians the path to take on their own quest from one of math's greatest secrets.